So the next example is going to be a little bit long, so I'm going to do it a little bit slower. So we have x squared plus 1 times x cubed plus 2 of this over x to the 5th power. Now, we have a quotient rule, but in this quotient rule, we also have a product rule right over here. So, to be able to do this quotient rule, we're going to need the derivative of this numerator over here. So, to avoid having a long line, we're going to take the derivative of this business over here in the numerator first. So we're going to treat it as a product rule, just as a simple product rule. So we're going to have, let's call this g of x. So let's say that g prime of x. So I'm going to do derivative of this thing over here only. So this is a product rule, x squared plus 1 times x to the 3rd power plus 2. So as the product rule says, we're going to take d over dx of x squared plus 1, then times x third plus 2, and then plus x squared plus 1, and then times the derivative of x to the 3rd plus 2. Right? So here we're going to have 2x times x to the 3rd plus 2 plus x squared plus 1 times derivative of this over here, which is 3x squared. Now let's apply this trivial property over here. We have 2x times x to the 3rd power, that's going to be 2x to the 4th power, then 2x times 2, that's 4x, plus 3x squared times x squared, is going to be 3x to the 4th power, and then we have 3x squared times 1 is just going to be 3x squared. So now we have a like term over here and then over here. Then we're going to have that g prime of x is going to be 5x to the 4th plus 3x squared plus 4x. I ordered them by their degree, 4 to 1, from greatest to least degree. So now we have find the derivative of our numerator in this function, right? So I'm going to get another paper over here, and then let's rewrite our function of the problem. So we have x squared plus 1 x to the 3rd plus 2 over x to the 5th. So let's set up now our quotient rule. So we have f of x. So we have the derivative of our numerator. Our numerator is all of this over here. The derivative of our numerator. So we have d over dx of the numerator, which is x squared plus 1 x to the 3rd plus 2 times the denominator minus the numerator, x squared plus 1 x to the 3rd plus 2, and then times the derivative of the denominator, which is x to the 5th power. And then, as we all know, all of this divided by x to the 5th squared. So now, the derivative of this thing over here, of the numerator, we just solve it. We know that is this business over here. So we're gonna replace it. So our previous process says that our derivative of the numerator is just going to be 5x to the 4th plus 3x squared plus 4x. That's the derivative of the numerator. Then as we follow the quotient rule, times x to the fifth minus, now I have this here, we have two terms, right? So I'm going to multiply them to make things easier. So I'm going to do this right over here. I'm just multiplying them. So we apply the distributive property, and then we have x. So we're gonna do this. I'm going to color code it. We're going to do this times this, and then this times this, and then this times this, and this times this. So we're going to have x squared times x to the third power. That's going to be x to the fifth power. And then we have plus x squared times 2. We're going to have 2x squared plus x to the third power plus 2. Right? So we have simplified our numerator. So we're going to plug this here over here. This is the same thing. We just are going to put it simplified. So we have the same thing over here, x to the fifth plus 2x squared plus x to the third plus 2, right, times the derivative of x to the fifth power, which we know is 5x to the fourth. And then we have all of this over x to the 10th power. Now we're almost done. We just have to keep multiplying, so let's do it. We're going to distribute this here, here, and here. So we have 5x to the fourth times x to the fifth. We have 5x to the ninth power plus 3x to the seventh power plus 4x to the sixth power, right? And then we're going to this distributive property. So we're going to have, and since we have a minus sign over here, all of this is going to get out as negative. So we have x to the fifth power times 5x to the fourth. That's going to be minus 5x to the ninth power. Then we have 2x squared times 5x to the fourth minus 10x to the sixth power. And then we have x to the third times 5x to the fourth. That's minus 5x to the seventh. And then we have 2 times 5x to the fourth. That's minus 10x to the fourth. And then all of this again, over x to the 10th power. So now let's look for some like terms. We have 1 over here, 1 over here, we have 1 over here, 1 over here, and we have another ones over here. So let's simplify. So we have 5x to the ninth minus 5x to the ninth. These are going to eliminate. Then we have 3x to the seventh minus 5x to the seventh. That's going to be minus 2x to the seventh. Then we have 4x to the sixth minus 10x to the sixth. That's going to be minus 6x to the sixth. And then we just have minus 10x to the fourth. So now we're almost done. And then we have this over x to the 10th power. So now I'm going to, let's see, we have to simplify this even more. So I see a common factor here of x to the fourth. So let's take it out. X to the fourth. Then we're going to have minus 2 inside remaining. We're going to have minus 2 x to the 3. And then here we're going to have minus 6 x to the 2, and then minus 10. All of this over x to the 10th power. So now what I'm going to do is simplify here. We're going to have 4 and 10 is going to be 6. So now our final answer is just going to be what remains here. We're going to have minus 2x to the 3rd minus 6x squared minus 10 over x to the 6. And this is the final answer of f of x. Now to prove this is the right derivative, I just did it over here with the calculator. So I have here derivative. I used the derivative function of the calculator and I plugged in the function when x equals 1, and it says minus 18.0094, and then I did it manually using my differentiation when x equals 1 and there's minus 18, the same thing. So our process is right.